then I try to dive a bit behind there and say like, hey, it's actually everything is open source, even the package, the entire package is an Astropy. Check it out on GitHub. Everything is open source, and this is, I think, also something super acknowledgeable. Like later on, stitching together the first picture of a black hole is been done by open source, right? And that is awesome, right? This is an awesome direction where also the corporate needs to take on the responsibilities. And then you have obviously contributions. Formalizing, organizing by himself. Papers with Code, how awesome is that resource? Kaggle, right? How awesome is these sharings, kernels about lessons, introduction, how to apply data science and keeping state of the art. I think that this has an impact, right? This is awesome also for industrial AI. But though I would say yes, it ain't that easy as we're checking out the GitHub project and applying it on the shop floor, right? The challenge in industrial AI is a bit different. And if I look in corporate world, right, then I don't know if you stumbled over that. This is Nigel, and he won the French Scrabble, right? By not speaking entirely French, but just memorizing every single French word, right? And this is, I guess, what machine learning in corporate still looks like. They don't have a clue about actually the real world, right? They have statistics on steroids and driven and its application, right? And this poses obviously some kind of challenges also. And let me give a bit of also a differentiation, because I think the contribution in the consumer space are quite awesome, right? But for most of the cases in consumer space, if you go to Amazon or go to Google, we don't expect 100%, right? We don't expect 100% accuracy in that kind of, because I'm okay, second rated, right? If the Facebook wall or the Twitter wall, right? I don't care, is it the first or third or fourth entry? We don't necessarily demand 100% accuracy. On the system task, I don't say 100% accuracy, but we need to be robust, right? We need to be somehow explainable, because if we move a robot system, it has a different impact, and that's why it gives this different directions actually, which we also see as challenging, right? When hitting from different perspectives, how to get started in industrial AI, which is a different realm. On the one side, obviously labeling data, right? If you do labeling data, obviously, ImageNet or, you name it, dogs, cats, computers, go ahead, right? Every dude I know, can label stuff, right? Or you distribute it in some kind of, startup company. But how do you deal with sensor information? That kind of like, is it an anomaly? Is it a failure? Is it just a mix-up? It's pretty damn hard labeling data in industrial AI, especially on sensory information. Second aspect is obviously the data is scarce, right? The net, I guess was invented for, in first place, connecting weird people, right? Second, cats, third, porn, and now it ended up as this gigantic, uncontrolled marketplaces which try to sell you everything, right? But it still has a lot of cats, right? So I guess, the data is there, right, for the distributions. In industrial setup, if your machines produces 100 million failures, we ain't gonna sell the thing, right? So we barely have some events, which actually our KPI, we need to, set the objective function to that, right? Third, obviously, is the cost of exploration. It's what it means, changing certain pyramids, pyramiding, and changing also the recommendation ranks. This is something different as if you want to have a control occupancy defined, right? First is obviously, if you have the prediction of the classification, right, and you change something, then a business person, and I don't know, you shut down a machine, then a business person wants to know why, because hell yeah, that costs 100K a day, right? If you shut down a machine, right? So you better have an answer why this machine thinks, it's better to turn the thing off. And that means, right, we need to provide also shop floor level some kind of traceability, but also explainability, and that not necessarily demands the web thing, right? Why is Facebook showing me that thing here, and you maybe trace down a bit, right? And the sixth one is obviously, inferencing with the physical world. Data in the virtual world is constructed in the virtual, it's applied in the virtual world and stays in the virtual world, somewhere in the natural world, right? Well, on the industrial you know, we need to cope with the physical world. So they are sensors and they're actors, and we need to measure something, and the world is changing and it's dirty and stuff like that. And that is somehow different. And that's why, you know, I see that obviously, you know, we love to go the way and say, like, you know, don't tell me anything. I just learned what I observed. I took a camera, and then you know, I learned it based inverse schematic of a robotic system, right? I don't care, you know, whether you can, or you say where we actually come from, you know, robust and reliable. It's like explicit knowledge to be modeled. And obviously, as usual, right, the hard stuff is in the middle, right? We need somehow, there are certain capabilities from, you know, especially computer vision aspects, forecasting aspects, which are really, really nice representation learning to make, really, really nice aspects. But then you have this massive domain know-how, this gut feeling, which is also pretty awesome. How do we model it, and how we bridge these worlds together? So let's share a couple of research what we do actually here. One aspect is if domain know-how is that of importance, right? How do we formalize this domain knowledge? And one of the main aspects in doing that is what's, you know, connecting, you know, turning strings to things, basically. Means like we digitize content, documents, and structured document along the information. Information is being captured, and the smallest instance of these are entities and relations. And it means building entity relations to each other, bounding in massive scale, is a graph. And this eventually ends up then obviously in what's called industrial knowledge graph, right? So, and this is a huge attempt also since quite some time, and where we think, okay, we need to deduce some tangible machine readable format of the legacy data we have. And it means from service documents, from drawings, from tables, from BOMs, from building of materials and building of products. This is what I call it. You know, doing triplifications, doing verification, and then doing query and inferences. So we can somehow try to formalize domain knowledge in a graph structure at scale, right? What do we need? We need, you know, structures, obviously. We need to turn things into things, right? This is what it's all about, and it's a great contribution by Pankaj Shibu, and also collaboration with LMU here, Munich, Henrik, thanks very much. On, you know, how do we learn the simplest format? It means like, how do we automatically, but also internal service reports, you know, extract entities as well as relations. And the important thing here is that obviously we need to learn relations across, you know, sentence boundaries, because we need to parse entire documents, and these needs to be validated. And the contributions made over the last years here, you know, is setting up a small engine of knowledge extraction. So we can, you know, structure and read and structure different entities to relation to each other, size products, size companies, size competitors, size suppliers. Currently also a nice collaboration. Hans Usgereit, I don't know if he's in the call here, with Pilas on that. At the same time, obviously, we need to, since we need to route them specifics, such as tickets, service tickets that are read automatically, structured automatically. We need to route it to different experts in combustion, in burners, in, you know, service level agreements. That means we need to also identify topics, topics within service tickets, topics within requirements, topics within certain kind of pieces of the production process. And this is also great from Yatin and Florian, a great contribution, right? What it means to be on topic modeling over time, because we also, again, right, we don't have this 100 billion corpus of text, but we do have, you know, service text on service repair reports, on certain aspects we need to be structured, and therefore we need to talk with short documents, but still learning the topic process of the time. This can be then nicely integrated. Once you have these components, can be nicely integrated, and such as, you know, tender comparison. So we have tender documents, 100 pages, 150 pages, right, which need to be analyzed and routed automatically. And these modules are then injected, and it's part of an engine in the tender process. Once we have a bit of a structure, once we have some kind of knowledge structure, we can apply obviously recommendation as well. In Siemens, it's called the TL selection portal. It's like the Amazon of of the shop floor, I would say. So it means like, you know, it's not about, you know, adding a t-shirt and some sneakers, right, to that, but it needs to be compatible, right? You build a line, you build, you know, I need the displays, I need a conveyor belt here, I need a controller there, right? And these all needs to be somehow compatible to each other, and the best recommendation for, you know, for your production, if you do brewery production, or if you know, do any robotic task production. And it turns out that these graph structures and tensor factorization attached to that makes really nice moves here. With a contribution on ESML, big up to Marcel and Ingo for you know, making here a great contribution, which is also in a TIA portal and integrated. Then you have obviously static knowledge graphs, and this is nice work from Silang and Yichang. It's piloted in Charité, Berlin. Contribution also, I think, triple times on Ichi actually, and on Lips. If you have a static knowledge graph, but you still need on patient data, but you still have some history on the patient, which is episodic memory. How do you combine those, like episodic and static knowledge graphs, to each other to learn individual treatment rules? This actually shows already, again, data-driven, but it's interesting questions to be asked here. The same goes with labeling. And this is work from Ishan and Florian as well, together with the Waltinger's colleagues, on, you know, what it means to actually a label of cell type classifications, which you see at the very down. And this labeling is really a bit of a crazy manual task, because it ain't that easy to distinguish with that. And what it showed is that you can learn representation and order it by their pseudo time, increasing as a pseudo inference algorithms, and order them by the pseudo time, and then the expert can label it as like, hey, we think that this is cell type, this is cell type, this is cell type, as a recommendation for the labeling, which is actually this year on the ICAI, actually will be presented. I think it's uprising. Apart from images and apart from text, obviously sensory information is pretty crazy. Sensory information, that means that we end up at streams like that. Somebody's, you know, workpiece drilling something, drilling holes in something, right? And we want to reflect from drilling the holes on the quality, right? I guess you all know this little fruit here. From drilling the holes, whether this is sufficient quality, and that's ain't easy, because you need to learn some kind of representation and do the clustering on this representation. Learn what is in a brownfield, like an existing sensory information. This is how it looks like. Or a good representation. Can we learn somehow quality inspect when it's throughput, when it's too rough on the edges? And it turns also out that, you know, tensor factorization does give us a bit. At the same time, also on if you talk about a grid level, because if you have grid and you have you know, Stromnetze, so distributed over a country. I guess you can guess the country here, and you need to identify, is there some kind of bird or, you know, something cut on the grid level, right? And how far is that distant? And it turned out we could also learn nice time series representation on full classification. What the heck is happening here? Is it a cut, right? Is somebody, a balloon just in there? Not, it's like, is it just a disturbance? And how close is to the next measuring statement, right? P means called, right? So representation learning does a stack, but what is missing is obviously, you know, we often deal with only a couple of evidences, and this is currently featured work of Ahmed on how do we deal actually with shoe shot and one-class classification, especially in anomaly detection. Because anomaly detection is super unfancy, I guess, in the incurred super, you know, computer vision task, but it's such an essential pillar in industrial AI. And that means, like, how do we cope when we need to cope with, you know, only a few shots that we have on data, and how we initialize that, right? MAML is a great contribution by the US folks there. Obviously on meta learning, but how do we adopt this meta learning algorithms to actually anomaly detection? This is great stuff from Ahmed to showcase. Okay, we can initialize, you know, on a few gradient steps then towards the anomaly detector. And on the other side, obviously, is if we build large nets, right, then these large nets need to be in an edge. Remember, I said like it needs to be somewhere on the edge level down there, right? It needs to have some energy footprint, it has some memory footprint, right? And what Yin-Chung showed here in a publication ICML is, if we can factorize and tensor train for the RNNs, actually, if we can factorize parameters into reduce the space there, right? Last but not least here is the aspect of softmax craziness, isn't it? If you train systems and you train the systems on certain data, and you somehow precondition it by that these domain stays fixed, but in fact, if we train a certain system and we change the domain, right? We put it out of the domain, then softmax does crazy things. Right, the last layer on the classification doing the distributions probably does crazy things, and so that means the trustworthiness is somehow different, and that's why we say like the one thing is confidences, obviously probabilities basically, and the other one aspect is actually is trustworthiness. Is, are you still okay in your domain? Do you think you are still in the domain, right? Or how far are we in or out of domain prediction? And it turned out that, the calibration, seeing that as a calibration aspects, and expected calibration error indicates very well, how the model matches to its confidence scores. And this is what's currently pretty hopeful. It was an internship by fantastic Christian and with contribution of Florian. On how do we deal with the calibration errors as a predictor for trustworthiness when we deploy from one factory to the next factory actually there. So when you have also contribution, and then mostly I guess in the scientific world, hey, we're done, we have a paper, right? It ends up, then it comes to management and banks you, right? And so like, no, it needs to hit the real world, right? You want to end up hitting the real world, and if you hit the real world, then you end up in a crazy somehow technology ecosystem actually, because that means 80% is sure quite stimulated by I guess open source momentums, but 20% are still somehow the proprietary software you need to integrate, right? Because there is a certain software running for 20 years, there is a certain piece of Windows running or of Linux or you name it, and you need to integrate it. It needs to be part of the process, right? And therefore you have some kind of capabilities, libraries, workflows, tools, and stuff like that, obviously, which are contributed, PyTorch, TensorFlow, and stuff like that, and the models itself as well. But then it actually needs to hit the real world, and it means on the shop floor. And that's for many cases, not only in Siemens. This is a survey from Algorithmia, great company actually, on stats, and what it means actually deploying these kinds of machine learning capabilities in productive. And it ends up that 90% never end up, right? They trapped in a proof of concept fail. They're tried out, but they never are operationalized, right? Because shipping something to productive is more than equipping somebody with a data science on a problem and say like, here's sample data and that, right? And kudos to Google here actually for a great paper. I highly recommend to every PhD here, reading that, the hidden technical depths in machine learning systems, because everybody is looking for this fancy, right? This is the surfer thing here, right? I'm a coder, right? But if you ship something productive, right, the complexity starts in the entire process around it, right? How do you get the data? How is it cleaned? How is it maneuvered? How is it updated? How do you deploy it, right? How is it managed? Where do you deploy it? How do you monitor it? And stuff like that. And that's actually the craziness, right? If you want to deal in making an impact with your research, right? Prepare for that. I can't just tell you that making it on GitHub is already cool, but document it, right? Test it, have it, don't come with spaghetti code. Try to incent your bias, making comments. You guys, that's crazy, right? Comments in code, how cool would be that, right? These kinds of aspects, software engineering perspectives, are really important also from a research perspective. Do that, right? And you can have an impact on that. And there are certain obviously challenging aspects in our environment. Is why ML is not hitting in that kind of scale as we want to have it, because a lot of aspects is obviously in a corporate manner. Everybody wants to do a POC, but nobody is saying, so, okay, what if that succeeds? What if that works, right? How do we deploy that? Oh, we need somebody from IT. Oh, hell yeah, shit. I don't know. I haven't talked to them, right? Then you have obviously the typical thing, especially if you, I don't know, if you folks then from the PhD out, go out in the companies, then you are the data science, and then you have to do the user experience, you have to design, can you do the web design please as well? And can you do the cloud architecture as well, and the software architecture? You know, don't mix it up, right? Be expertise, you know, open up to teams and make DevOps, right? As a team structure, not as a single player, you know. The third one is obviously on technology, right? Tightly integrate, but loosely coupled. You know, you will not, you know, you always have to integrate in some kind of component. So abstraction, you know, don't lock in, right? It's all about abstracting, right? And fourth, obviously, it's champions, right? Be an expert, be a champion something. I always say it's, you know, use cases that have not support by C-level will never see the light, right? This is, as Diego put it as well. I think that's a strong combination. So, you know, just selling technology ain't a good thing. You need always have stakeholders involved, and that's, you know, involve the people, and then you can convince, you know, also to get deployed. And this obviously happens for many reasons, right? We'll observe 60,000 events per second, you know, when our CNS infrastructure is obviously somehow exposed for hacking, right? So we want to make sure, you know, we keep it safe as the bad guy shooting with, you know, AI and machine learning. You know, we're trying to protect obviously the infrastructure at the same time, right? By, you know, what kind of URLs are called, and easily called malicious is they're registered by, you know, some kinds of crazy rules or kind of crazy formats, right? The same goes for, you know, deploying then on tolling, you know, need to deploy it, then and need to deploy it means on this little machinery is a secret too, right? It needs to run there with memory footprint attached to that in order to be executed and be used, right? And the same goes for 3D printing. But one thing is obviously, and this is nothing new actually, especially in the German and European, I guess, ecosystem, because they're all fed up with machine learning anyway. They're like, let's talk about, you know, cognition again, right? Obviously, causation is something different, right? And a great thing is, this is from Google actually, right? Is as an example of, you know, capture generation, right? You put a photo in there, and then, you know, it generates the description: 2 men on a surf bus riding a small wave. Awesome, right? For fucking sake, it's this little small fella identified and said, okay, these are 2 surfers, right? And correlating the stuff together. On the other side, the real world is a real world, right? And even though I never saw this course somewhere, right? Peter Norvig has had a great job of that, right? And it's obviously how fragile these systems are, these data transmitters, right? A couple of tutors standing next to each other, and you would say, oh, fuck, that's Google AI, honestly, right? And you would say, you know, it's so fragile. It's so fragile, this data-driven thing, right? Because think of the French guy winning Scrabble, right? And the same goes here, right? Reflection of the dog. How can it be, right? This is not doable, right? In industrial AI, right? And the same goes. It hits the real world, even though this video is not shared, right? It doesn't activate because of the color of the skin here, right? Because you know, if you deploy AI systems, yeah. You need not only take care about the algorithm themselves, but you need to observe the entire process. Where's the data come from? Is the data changed? You know, who changed the data? Who cleaned the data? Who massaged the data? Who built the data? What does the data actually learn from, right? When was it deployed? What is the firmware update, right? You need to have an entire thing on, you know, on the entire process on deploying continuously in order to have a bit of a more robust and reliable thing, right? And once it's clear, obviously, you know, there's no unbiased data. I've seen already some corporates and some startups telling me that they have an unbiased button. Go home, no way, right? Data is always biased in some kind of manner, right? And I think this will, even, you know, in current internet craziness times, will be much more, you know, craziness, because the application, especially in the web domain, and, you know, I guess Clearview, you've seen it, right? Scrapping every image you find, you know, every selfie of yourself, you know, being in a database, and now, you know, sold to law enforcement. I'm not sure we are in a good way here. We're in a good path. So researchers, please, you know, reconsider, right? If you go into corporates or to startups or whatsoever, reconsider some kind of structures, you know, where we want to end up with this, you know, also data-driven craziness. It is also not only the corporate, but also our, you know, our own responsibility to rethink about where do we want to transform ourselves here, right? One attempt which we do, and this is the last 2 slides, Matthias, before you kick me out here, I guess, is an attempt that we have that we try to reflect on what's called a responsible AI framework, where we do classify and reconstruct on all use cases that we have. It runs like that you have certain capabilities. We classify each use case or each application that we can do or we pursue in certain kind of pieces like visual monitoring or companions or autonomous systems, stuff like that. They have obviously quite some capabilities, manage a lot of capabilities, higher system efficiency or failure reduction or, you know, zero harm infrastructure. But we need to be aware of, and also management needs to be aware of that this comes with some risk, isn't it? And these risks such as misuse or black boxing or right error or, you know, inability to control or, you know, bias as well, are certain kinds of risks we need to be attached and needs to be considered before implementing that. And that gives us a bit of indication and a bit of a framework how to structure the discourse with management on, you know, what is a responsible use of AI and what kind of mitigation scenario do we need to, can we somehow run federated learning algorithms on that? Do we need to secure prior data before we send something? Can we execute certain pieces on the edge itself so no data is being sent out and stuff like that? These helps motivating and also guiding a bit of the decision making in management. We're working also and released the first set of a bit of principles towards, you know, explainability and what kind of commitments. It's easy to put that in a corporate manner, believe me, tough work. What I want to leave you with, you know, 1,000 of challenges. Please get it on, right? If you, and it's great work from Eric as well. You know, the research challenge we deal with scarcity. That means active and transfer learning, simulation, alternative models, right? Knowledge induction. What is industry embeddings? We are sick of a bit of the Wikipedia embeddings, right? What does that do to us, right? Companions. What, you know, what is actually, you know, context-aware decisions? You know, who do you augment? How do you implement actually, you know, companion decision support systems in current times? Society, obviously, you know, what explainable models, because we're hitting the real world, what is transparency, but also fairness. And open world, obviously, right? Trustworthiness and robustness will be the key this year, I guess, it will be seen throughout Europe. With that, I hope I wasn't that fast. And if you are interested, join us for the residency program. Currently, we have 3 residents on, you know, on postdocs or PhD level. Soon, starting next year, unfortunately, the next batch will start. So kick off in autumn. Ping me a mail if you're interested. Thanks very much.